All right, so we're going to be looking at section 8.5, graphing polar equations. We're going to be graphing polar equations, but we're going to be focusing on really just only two types, the Rose curve and the limit-shot. We'll be using the graphing calculator to assist us in graphing and identifying key points. So it's going to be on the calculator, all right? Let's look at the Rose curve. The Rose curve is the standard equations, this one or this one. We have some number out in front, the cosine of n times theta. N is an integer greater than 1. If n is an even number, then there will be 2 times n number of petals. So if this n is 2, there will be 4 petals. If it's a 4, there'll be 8 petals. If it's an odd number, then that's how many petals there are. So if it's a 3, there'll be 3 petals. If it's even, you're going to need all the angles between 0 and 2 pi to complete the drawing. But if it's odd, you only need the top half of the unit circle. So in other words, from 0 to pi. We'll draw the complete curve, and then the bottom half we'll draw, just repeat the curve. So I'm going to show you how to do the Rose curve and what we're looking for, and how I want you to present your information. So we're going to do an example. We're going to graph 4 times the sine of 3 theta. You're plug in angles, and you're going to put it in a table. You have to make a table of key points. Okay? So you go to your calculator. Go to the graphing page. Once you're in a graphing page, it's in function mode. You're going to change the mode. I go to graph type and go down to polar. And you'll see that it has an R of theta equals right here. So you want to type that in. Make sure you're in radian mode on your calculator. Put a times between. And theta is down here at the pi button. Down here is the step feature. So theta goes between 0 and 2 pi. You can see it right there. And then how do I want to step? Well, you can get all the unit circle angles and a few more, but to get them all, and so they'll step through all of them, you need to step by pi over 12. If I erase this right here and type in pi divided by 12, then I'll get 1/12, 2/12, which is pi over 6, 3/12, which is pi over 4, and so forth. So I'll get all the unit circle angles, plus a couple more. Okay? Once I have that, just hit enter, and there is your Rose curve. See, there are 3 petals. You are going to graph that on a polar coordinate system. Okay? But I need to know what angles make the ends of the petals and what angles make 0. Okay? So you want to have the key points are when is it 0 and where is the endpoints of my petals. All right? So we have a trace feature will help us do this. Go to menu, go to trace, the graph, and start at angle 0. At 0, I have 0. So at 0, I'm at 0. Okay? The next angle I want to do, remember, I'm trying to find that endpoint out there. So where would that be? The next angle on the unit circle is pi over 6. So we can just type in pi divided by 6. Pi divided by 6. And sure enough, that gives me that endpoint, which is at 4. Okay? So you can also look here and say, well, what the sine of an angle, forget that it's 3 theta, the sine of an angle is largest when the sine is 1. So what angle makes that sine equal to 1? Well, it'll be pi over 6. So pi over 6 is 4. That's one of our key points. And just go through all the circles here. Okay? So let's go to pi over 4. Is that a special angle? And I just use the trace feature. No, it is not. Okay? The next one would be pi over 3. So pi divided by 3. And it is. Pi divided by 3 is a 0. Okay? So pi over 3 is a 0. The next angle is pi over 2. And that is down here at the bottom. So pi over 2 is -4. And if I look at this and I can see what the main angles are, you can see that pi over 4 is not going to be one of them. But the 6's and the 3's are. So the next one over would be 2 pi over 3. 2 times pi divided by 3. Back to 0, which corresponds with that one. And then we have 5 pi over 6. And that's the other point out there, and that's 4. And the last angle would be pi, and we should be back to 0. And we're back to 0. But you can see the pattern emerging here that will help you out with some of these things. The pi over 6 is here, and the pi over 2. The pi over 3's are the zeros, along with the 0 and the pi. So these are you need to make this table. I want to know the endpoints of a pedal. I want to know when it's 0. All the other angles I don't care about. And then you need to draw this on here. Each ring is 1 unit. So going and graphing this, we have 0, 0 at pi over 6. Now, take a look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is by 12ths. So this is 1/12. This is 2/12, which is pi over 6. That is pi over 6. Okay? 4/12 is right here. That is pi over 3. At pi over 6, 1, 2, 3, 4. There's the dot. At pi over 2, walk backwards 4. 1, 2, 3, 4. And at 5 pi over 6 is that 4. Okay? And then all the zeros are right there in the middle. So in drawing this, it's a smooth circular action. So if I start at 0, then I do a little curve out to there, come back around, continue on to that one, come back around, continue to that one, come back around. And that is the curve right there. Okay? So I'll be looking for the graph in the right spot. I'll be looking for the table of the key points. All right? That's what I'll be doing for a rose curve. And you can see how I did this one over here too. Graph on the calculator, use the trace feature to find the key points, which is when it is at 0 and the endpoints of the pedals. Okay? This one right here, the Limit-John curve, has an A plus or minus a B times sine, or an A plus or minus a B times the cosine. And here's the key things about this one. You're going to have something that looks like this with an inner loop, or it'll come to a little point. It's called a cardioid because it looks kind of like a heart. If this A over B is less than 1, I'll have an inner loop. If it's equal to 1, I have this little pointy thing. And if it's bigger than 1, this part right here diminishes, so it's less pronounced. okay? You'll see as you do your graphs. The sine curves, the ones with sine in it, this thing will be up and down action. So the graph will be mostly on the y-axis. This point will be on the y-axis, this will be on the y-axis. But if it's a cosine, then this loop will be on the x-axis, this will be on the x-axis, and so forth. It'll be like this. These kind of look like what a cosine would look like. And if it was like this would be like if it was on the sine. Okay? Your key points, if you can find them, sometimes it's harder to find, is basically look for all the intercepts. Look for the x and y intercepts, the zeros, that's what you're looking for, if possible. Right, sometimes the zero might be hard to find. So we're going to graph this one, and we want to make a table for it. I don't know how many points I need. We're just going to see how many we have to do. The first thing we do is we graph on the calculator. So let's get a new page. Let's go to graph types and polar and type that in. I'm still going to go pi over 12. For my step. And I'm still going between 0 and 2 pi. So there is my curve. Okay? You can see that is a sine curve. So this is all on the y-axis. Okay? So we go through here and we can do our trace. Let's get this out of our way. Menu trace. And we're looking for key numbers. So let's start with angle 0. Angle 0, I'm at 2. So when it's at 0, I'm at 2. The next angle, pi over 6. Let's see what that does. Not much of anything. You can use it to help you draw this curve if you wish, okay? Because the more points you have, the better your curve is going to be. What's pi over 4? Still no, but again, it helps you draw the curve better. How about pi divided by 3? Excuse me, pi divided by 3. Still no. Well, we can see clearly that it's going to be up here at pi over 2. So what is pi divided by 2? 5. So you can see that the next major point is going to be right over here, right? And that would be at angle pi, wouldn't it? So I know pi is going to be negative 2. Actually, it would be positive 2. Let's check it. Pi is positive 2 because I face pi and walk forward. Now the inner loop, okay? So what comes next? Well, what is it? Where is 3 pi over 2? Is negative 1. So that's the top of the loop. So this little 0 right here is kind of hard to get, but you can see that it's going to be at 0, 0. You're not going to be able to list that one because we won't be able to find it. And then if we do 2 pi, I am outside of my range. Remember, we define it between 0 but less than 2 pi. But you should get the same answer you got right there. So we want to draw this now. we know what it looks like. We're going to have a dot here. We're going to have a dot here. And we're going to have a dot up here at 5. We have a dot here at 2. We have a dot here at 2. And so this is the inner loop. And it has to go around like that. Okay? So down here, come around, and just do the best you can. Make the inner loop, and make sure you draw that out like that. So that's what I'm kind of looking for. All right, it doesn't have to be pretty. Again, if you put in more dots, you'll be much more rounded. It looks better. This is kind of bad looking. I would probably do much more dots to make it look better. But that's the idea I'm looking for. The table is going to be important. Without the table, I will mark you off. Okay? So this is what I'm looking for. And we'll practice this in class. It's in this video.